Hello, I believe you're all doing well. I want to look at a different year, do a review on some WASSCE questions, especially for those who are about to write their WASSCE examinations. And as usual, we normally would add pictures to these questions so that when we are explaining the answers, you can easily understand them. Alright, so the first question, a piece of iron rust when it comes into contact with air only, moisture only, oil only. So the answer is for air and then moisture only. Now if you look at the diagram we have here, you see this is an experiment to demonstrate or to look at the factors necessary for rusting, or the conditions necessary for rusting to occur. So the first what happens is that you have a nail dipped into water, and then there will be air here, although there is a stopper around here. Now over here too, you have boiled water. The reason why boiled water is used here, because when you boil water, the air dissolved in it will be removed. So boiled water has no dissolved oxygen or dissolved air, because air happens to be one of the factors that affect or causes rusting. Now the oil there would also prevent the air here, remember air was here, the air here from dissolving in the water to get to where the nail is and cause it to rust. Now over here you have dry air. The dry air is telling us that there is no water here. Now the dry air is caused by this chemical. We call that anhydrous calcium chloride. Whenever it is used, it's able to absorb water. That is why it's called anhydrous. Any substance which is anhydrous is able to absorb water from the environment into itself. It draws water. So when you put it here, it's going to draw the water from the atmosphere, from surrounding the nail into itself, so that now this nail wouldn't have any water. Now realize that rusting only occurred here. Why? Because over here there is no air. Although there is no air. Over here too there is no water, but there is air. Now over here there is air and then there is water. That's how come this one would rust. So it shows us that air and moisture or water would cause the iron to rust, or the nail to rust. Now vegetative propagation method is used in cultivation of what? Banana. Now this method, as we said over here, it's a method of cultivating crops which has no seeds, and we do this by using a part of the organism or plants. For instance, a banana, we don't plant their seeds. So how do we then grow them? By using what we call vegetative propagation. So vegetative propagation is a way of what? Cultivating plants without the use of their seeds. So normally we would either use a part of the plant or the whole. For instance, cassava, sugarcane, all of them don't have seeds. So they are cultivated by using, for example, cassava, you cut the stems and then you put it in the soil, as well as sugarcane, rose flower, pineapple as well. Pineapple has no seeds, so you cut the crown, the top part of it. All these are vegetative propagation. But if you look at cocoa, cowpea, pawpaw, all these produce seeds, so you can cultivate them using their seeds. That is not vegetative propagation. Cultivation of plants without seeds, but using parts of the organism is vegetative propagation, is banana. Now question 3, which of the following devices alters an alternating current? So alters here means it changes an alternating current. Now let's take note that alternating current is a type of current that flows in both directions. As in, it goes, let's say, from left to right and then right to left. So like this, something like this. Then there's also another type, we call it the direct current. That one moves in one direction. Now over here, these devices here, diode happens to be a device which will change an alternating current to a direct current, so that it will have just one direction. Take note that I just said alternating current, just like the name, alternating, it changes direction. So a diode is normally used so that it will cause an alternating current to only flow in one direction and become direct current. So it's a semiconductor device that essentially acts as a one-way switch. So that's the meaning, one-way flow for current. It allows current to flow easily in one direction. That's all about diode, allowing current to flow in one direction. It severely restricts current from flowing in the opposite. So that is that. So basically, diode changes AC to DC by making it to flow in one direction. Now, so it is A. Number 4, it is obligatory to wear glasses in the laboratory when handling substances that will emit sparks, little particles of light and heat, especially doing welding. When metals are being welded, you need to wear glasses. Is very important so that you don't cause damage to your ears. And number 5, the function of the pinna. Pinna is the outer part of the ear. What we normally see is to receive and what refract sound waves. In other words, it acts as a receiver. And refract in this case means that it will bend the sound wave so that it will enter into the ear. Now let's look at number 6. An atom of an element X has 23 protons, 26 neutrons. What is the number of electrons? So over here, what we do is that from principle, the number of protons of any atom is the same as its number of electrons, so that it is also the same as its atomic number. So for example, there is another way they can ask this question, is to give you the atomic number of an element, and they ask you what is the number of protons. So for example, if you are told that the atomic number of an element is, let's say, 13, then because the atomic number is the same as the number of protons, number of electrons, then the number of electrons that atom would have would still be 13. Number of protons will be 13. Now the reason why the number of protons is the same as the number of electrons is it's why we say that atoms are electrically neutral, meaning that their number of protons is the same as the number of electrons. So they are not. Now take note that protons are positively charged particles. Electrons are also negatively charged. So if the number of the positive charges is the same as the number of negative charges, then they will balance, it will cancel, so it will not have any charge. So that is why we say atoms are electrically neutral. It's one of the questions that you could be asked. Explain why atoms are electrically neutral. Because the number of the positively charged particles, into bracket protons, is equal to the number of negatively charged electrons, called the called electrons. So they cancel out, leaving no charge. Number 7, diseases that are easily transmitted from one organism to another through a vector is said to be contagious. Infectious disease are normally diseases that would be caused by a pathogen. Alright, now so let's move on to number 8. An effort of 100 Newton is applied to a machine to raise a load of 400 Newton. An effort of 100 Newton is applied to a machine to raise a load of 400 Newton. Determine the mechanical advantage. So mechanical advantage is basically the ratio of the load to the effort. So it is a way of seeing how effective the machine is. So that you see, you are applying a certain effort to raise an object which we call the load here. Now you are trying to see whether the effort you are putting in, whether it's really doing any great work. So that what it means is that if the load here is small and then your effort is less, then it means that you are doing much work. So you are at an advantage. So that's the whole meaning of the mechanical advantage. Now, if the load is, let's say, small, and then you have to use so much effort, then that's a disadvantage. So normally it will decrease. The number here will decrease. So let's remember that this is a formula. Mechanical advantage is equal to the load over your effort which you are applying, so that you know whether you have an advantage mechanically, or whatever effort you are putting in, you are producing meaningful results. So 400 divided by 100, that's 4. So mechanical advantage has no unit. That's one thing about mechanical advantage you have to know. Okay, now which of the following characteristics features in leaves of flowering plant ensure efficient photosynthesis? The narrow leaves with small surface, presence of veins, presence of stomata, thick leaves. Alright, so you realize that it's B. It isn't C, so it's B, because you need the presence of the veins would help in the transport of water and the mineral salts so that it can be used for photosynthesis. Presence of stomata, which are tiny pores, would also allow for the exchange of gases. Carbon dioxide will enter, and then it will be used for photosynthesis. And then when photosynthesis has occurred, the oxygen that will be produced will move out through the stomata. Now, when the leaves are thick, it's difficult for the gases to penetrate or get to certain parts of the leaves. So normally leaves are thin. Now over here, usually the leaves are broad, generally speaking, so that they can absorb much sunlight. So when the leaves are narrow, it wouldn't favor or make photosynthesis efficient. It wouldn't favor photosynthesis or make photosynthesis efficient. So let's take note of that. Okay, now let's move on to number 10. The vacuum between the two silver surfaces of a thermos flask prevents heat loss by oil. So let's look at the diagram here. So we are referring to this vacuum, the white area. Now, a vacuum is basically an empty space. Vacuum prevents heat loss or gain by conduction and convection because the vacuum has no material medium. What we are saying is that in order for it to transfer heat from one area to another, you need something in between so that it will carry the heat. But for a vacuum is empty space, meaning there's not even air. So the air wouldn't even carry the heat. So there's nothing that will help to carry the heat. So if this side is a vacuum, what it means is that if the inner side of the vacuum is heated, it will not carry, there's no air to carry the heat to this side. So it means that over here it's going to prevent heat loss to the outside or to the surrounding. So the vacuum here will prevent heat loss from the hot liquid toward the outside. So let's take note of that. Now, so it does that by preventing convection. Convection is the transfer of heat through air and then liquids, or through gases and liquids. Transfer of heat through gases and then liquid, that's convection. So over here, vacuum would prevent that convection from taking place. And also conduction, in the sense that they do not, the vacuum will not allow the surfaces to touch, so that they will transmit what the heat, because conduction is the transfer of heat through a solid medium. So because it's a space, it doesn't allow the surfaces to touch, so that it will transfer heat by conduction. Alright, now let's take notes. This is also one common. So silver surfaces, realize inside within the vacuum flask or the Dewar flask, it is silver, shiny. The reason is that it will prevent heat loss by radiation. So what it means is that if the heat is sort of emanating from here, trying to find its way to other parts of the flask, the silver surface will reflect it back, because we know that smooth surfaces are able to reflect waves, heat back or radiation back, for especially to create a regular reflection. So that's why the inside is silver, to reflect back heat into the liquid, so that the liquid remains hot. Because if the inner surface is not silvered or smooth, it's going to absorb the heat from the liquid, and the liquid will get colder. So, but when it is silvered or smooth, it will just be reflecting the heat back into the liquid. And then the plastic stopper, because it's an insulator, it's not a metal, so it will not allow, it cannot conduct heat. Plastics are usually poor conductors of heat. So conduction, it will prevent heat loss or gain by conduction, because itself, it cannot conduct, it's not a good conductor of heat. And also because you are use a plastic stopper to prevent air from moving out, you're also going to prevent heat loss or gain by convection. so that you don't have the heat moving out, or you don't have cold air entering in to make it cooler. Take note that this can also be used to keep cold liquids cold. So it will also do that using the same principles that we have discussed. Now, number 11, the soil may lose its fertility through leaching. Leaching is a special type of soil erosion in which nutrients are lost from the soil, and then they go out of the reach of the roots of plants. They go deep down, so the roots of the plant are no longer able to reach it, and then they do not grow properly. So that's what we call leaching. So a soil may lose its fertility through leaching. Now, number 12, the function of the solar thermal collector in a solar panel is to trap heat from solar radiations. Trap it. So collector will trap the heat. Now, let's move on. Number 10, which of the following factors affect the rate of evaporation from the skin of humans? Now, humidity. Humidity talks about the amount of water vapor in the atmosphere. Now, the thing is that just like nature, things will move from an area where it is more to an area where you have less of them. For example, heat, for instance, will move from a place which is very hot to a place which is very hot, cold, or is colder. That is why when you touch a hot object, after some time, the heat is transferred to you, the person who has a lower temperature. In the same way to water, humidity, as I was saying, it talks about the amount of water in the atmosphere. There's water in the atmosphere. Sometimes the water gets so low, and then you feel the dryness in the air, especially during Harmattan. The water in the atmosphere gets so low, and you can feel that the air you are breathing is so dry. It's because the humidity is very low. When humidity gets high, then you don't feel that again. Now, for evaporation to take place, or let's say in this case sweat to evaporate from your skin, humidity should be low. You realize that during Harmattan, your sweat, things get dry faster. Why? Because the atmosphere itself has less water. So wherever there is more water, it can move from that source into the atmosphere easily. So humidity is one factor which affects the rate of evaporation. When humidity is very low, evaporation is high. That's how come clothes or wet materials dry faster during Harmattan, because the humidity is low. There's less water in the atmosphere. Now, temperature could also be a factor. The higher the temperature, the faster the evaporation. Just like heating or boiling liquid, as the water gets hotter, you see evaporation taking place. So, but if it's cold, evaporation is difficult to. It's not as much as when it is hotter. So temperature is also a factor. And then the speed of the wind. The more the wind is blowing, the easier evaporation can take place, because it will blow away the already evaporated water, and then allow for more evaporation to take place. So pressure is in part. So humidity, temperature, and then wind speed. Blood vessels in the mammalian skin constrict during what? During cold weather. When the weather is very cold, your blood vessels become smaller. That's the meaning of constrict. There's a reason they do that. They do that because blood inside your blood vessels carry heat. Your blood is usually hot, warm, and that's what gives heat to the rest of your body. So what happens is that during cold weather conditions, because your body is trying to conserve heat, because if your body does not conserve heat, then you lose all the heat. You will feel cold, and then it will also result in something else. So the body tries to make certain changes in your system so that you can contain heat in your system and not lose heat. One of the things the body does is to make your blood vessels to constrict or shrink. They go deeper into your body so that they are not at the surface to lose heat easily. So one of the observations is that usually, not all the time though, during cold weather conditions, you don't see much of your veins. It might be there, but it's not as visible as it is when the weather is very hot. When the weather is very hot, the opposite happens. Your blood vessels will dilate, or they will come to the surface. They become wider. They come to the surface of the skin so that they can lose more heat and then keep you your temperature at a cooler level. Now, an example of a root tuber is cassava. Root tuber is cassava. Now, number 16, total eclipse of the sun is seen when the observer is in the amber region. So this is total eclipse of the sun. What happens is that the moon is between, so during eclipse of the sun, the moon is between the sun and the earth, so that the moon will now be the opaque object which will cast its shadow upon the earth, like what is happening here. Now, when it casts its shadow upon the earth, there's a region of partial darkness. See, this one, the darkness is not that much. Then there's one in the middle, very dark, totally dark. We call that the total eclipse, or we call that side the umbra. Umbra means total darkness, and then penumbra is the shallow one. So normally when total eclipse occurs, there's not every part of the earth. Look at the globe here, or the earth here. You see that certain part of Africa would experience partial darkness, but certain parts, especially around Ghana, Nigeria, and those areas, the coastal areas, they were going to experience total darkness. So I think that some time back, around was it 2005 or so, we experienced that in Ghana here. So this is what happens. The whole place becomes totally dark. Then you see the moon in front of the sun. So obviously it means that the total eclipse of the sun is seen when the observer, so these people are observers, they are inside the umbra region of the moon's shadow. Normally, if you are in the penumbra or other areas, you may not see the eclipse. You may not see it like this. It is only those in the umbra region who will see it like that. Number 17, a solution contains 18 grams of glucose per dmq. Determine its molarity, given that the molar mass is 180. Take note that molarity has to do with concentration. Molarity is another name for concentration, and concentration, the formula is it talks about the amount of substance dissolved in 1 dm cube of a solution. So to find the molarity or the concentration of a substance, you need the amount of substance and you need the volume. When we go back to the question, the volume has been given as 1 dm cube. However, we do not know the amount of substance. Now, the amount of substance, look at this formula, is gotten by dividing the mass of the substance by its molar mass. Take note, the two are different. Molar mass is not the same as the mass of the substance. Molar mass is the mass of 1 mole of the substance. Just like its name, molar mass is the mass of 1 mole of a substance. So to get the amount of the substance, so that you can put it inside this formula to get the concentration, we divide the mass of the substance by its molar mass. And from the question, the mass of the glucose is 18 grams. We divide that by 180, which is the molar mass. We have 0.10 mole. So we now bring the 0.10 mole back into the molarity or concentration formula. And then, so the volume is 1 dm cube. Just like that. So we put it inside, and there's this answer showing that the answer is C. Now, number 8, which of the following methods could be used to demagnetize a strong magnet? Okay, so basically when you say demagnetize, this is the process in which a magnetic material loses its magnetism, so it is no longer able to attract or let's say repel other magnets or magnetic materials. Just like the word D has to do with removing something. Demagnetization, removing its magnetism. Alright, now look at the ways of demagnetization is to heat the magnet to red hot. When you heat it to a certain point, it loses its magnetism. Then when you hammer continuously also, the magnet can lose its magnetism. And also when you apply an alternating current, AC, that's what we referred to previously, AC a type of current which changes direction, moving in both directions. When you apply it to, and that's the current that normally comes from our socket and all that. Now, when you apply that to a magnet, it will no longer work. And also, you could apply a strong magnetic field. So you can use another magnet field, especially a very strong one, and then they can use it to remove the magnetism of another magnet. Now let's look at the diagram here. So the diagram here illustrates a farm equipment. Let's use it to answer questions 19 and 20. The diagram illustrates is a watering can, and then number 20, it is used to sprinkle water on plants. So we would continue with the rest of the questions later. Thank you.